I feel the anxiety level increase across the city of Reading as students read this problem. Let's see if we can't figure this out. Carol and Jan leave the same place and travel on the same road going the same direction. Really? They leave the same place they leave from the same place and travel on the same road going on the same direction. Okay. Carol walks at a rate of 2 miles per hour. Okay, we got her rate. Carol left 5 hours earlier than Jan. Oh. So if I think about this, if Carol left 5 hours earlier than Jan, that means Carol's been walking longer, right? Right? Because when Jan leaves, after Jan's been walking for 1 hour, Carol's been walking for 6 hours. Who walks for 6 hours? Okay, Carol left 5 hours earlier than Jan, but Jan bikes at a rate of 6 miles per hour. How far did they travel when Jan caught up to Carol? Oh, I want to know when their distances are the same. Okay, so I'm thinking a table. Let's see if we can organize this. We definitely got the rate for each person, the time, and we've got the distance. And we've got two people participating. We've got Carol and we've got Jan. So a couple things I know, right? The rate for Carol was 2 miles per hour. The rate for Jan was 6 miles per hour. If Jan walked for X hours, or if she bikes, right? If she biked for X hours, because Carol was going longer, Carol, it's in fact 5 hours more, right? She left 5 hours earlier. Carol would be X plus 5 hours. Okay. And I do know that distance equals rate times time for both, right? But what I really care about is that I want to know when these distances are the same. So if I write this, right, I can write the distance equals the rate times time. So 2 times the quantity x plus 5 is Carol's distance. And for Jan, it's 6 times x. Well, I want to know when those distances are equal, when they're right next to each other, when Carol caught up. So what I'm going to do is I'm going to set these two distances equal to each other. And if I set them equal to each other, I can definitely solve for x. So distance is equal to distance in this problem. So 2 times x plus 5 is equal to 6x. And I don't know why I'm writing the let statement now, but let x be the time that Jan walks in miles per hour. No, Jan doesn't walk. Jan rides her bike. So then 2x plus 10 is going to equal 6x. 10x is going to equal 4x. And x is going to be 10 fourths or 5 halves. Okay, so we know exactly what x is. And at this point, I think we're ready. All right, so we got here that x is 5 halves, right? Which is what, 2.5 hours? But that's not the question. The question is, how far did they travel when Jan finally caught up? So if I take this x value and plug that 5 halves into it, I get 15 miles. And that's true for both equations, right? If I take the top one, I take 5 halves times 6. 5 halves times 6, that's 2.5 times 6. That should be, let me check that out. Maybe I'm wrong. 5 divided by 2 times 6. Yeah, it's 15 miles. And same thing with the other person. If I take a time of 5 halves plus 5, right? 5 divided by 2 and then plus 5, that's 7.5 hours this person walked. 7.5 hours times 2 miles per hour, that's 15 miles. So they both traveled 15 miles. All right, that's it for question 30.